Good night, all of you. My name is Omar Cano. I am an economist student currently enrolled in the business communication course. Today, I am to raise awareness about a critical environmental issue, the impact of industrial dish soaps on our ecosystems. Throughout this interview, we will compare traditional chemical detergents with eco-friendly alternatives to help us understand the environmental and economic implications, specifically focusing on the brand EcoGlow. We are joined today by a specialist in the field chemistry, Ignacio Hernandez. Welcome, Ignacio. Let's begin.
Hello, I am Ignacio Hernandez. I am a chemist and I'm here to answer a series of questions regarding the ecological dish soap EcoGlow.
Nowadays, we will continue with our round of questions. The interview will consist of asking and answering remotely due to Dr. Ignacio's very vast schedule. Let's begin the first block. One question. Degreasing power. Chemically, who's using an eco-friendly soap break down animal and vegetable fat molecules without using aggressive synthetic surfactants like algals, sodium lauryl sulfate? Nowadays, we will continue with our round of questions. The interview will consist of asking and answering remotely due to Dr. Ignacio's very vast schedule. Let's begin the first block. One question. Degreasing power. Chemically, who's using an eco-friendly soap break down animal and vegetable fat molecules without using aggressive synthetic surfactants like algals, sodium lauryl sulfate?
Instead of synthetic sulfates, eco soaps use natural surfactants derived from sugars or vegetable oils. These molecules possess a dual nature, a hydrophilic head and lipophilic tail. They reduce surface tension, allowing the soap to emulsify grease into tiny droplets that are easily washed away by water.
Question number 2. Hard water reactivity. In many cities, water is a high in mineral content. How does a natural kitchen soap formula react to a boil living with spoons on glassware?
Hard water contains calcium and magnesium ions. Traditional natural soap can react with this to form soap scum. Eco-friendly formulas incorporate natural chelating agents like sodium citrate or gluconates that trap these minerals, preventing them from depositing on surfaces.
Question number 3. Cold versus hot saponification. For this soap, which chemical method ensures a more stable and durable product, cold process or hot process?
While both create soap, hot process is often preferred for these soaps. The heat ensures the reaction is 100% complete, resulting in a more alkaline, cleansing focused bar with lower superfat, excess oil, making it more effective at stripping grease and more resistant to dissolving too quickly in water.
Question number 4. Chemical residues. What truly remains on a plate after rinsing with conventional soup versus eco-friendly soups? Is there a risk of ingesting chemicals?
Conventional soaps often leave a film of synthetic fragrances, optical brighteners, and plasticizers. Some studies suggest cumulative microingestion of surfactants like linear alkylbenzene sulfonates. Eco soaps use biodegradable molecules that rinse off more cleanly, significantly reducing the toxicological risk.
Question number 5. Drainage impact. Once it goes down to drain, how long does it take for this soap to fully biodegradable before reaction reverse or cease?
A truly eco-friendly soap is readily biodegradable, meaning 60 or 70% of it breaks down within 28 days. Synthetic surfactants can persist for months, especially in aerobic conditions, where they become toxic to aquatic life.
Let's now move on to the second set of questions that talk to us about the composition of eco-friendly kitchen soaps. Sixth question. Recycled cooking oil. It's the chemical viable and safe to transform use the cooking oil into dish soap, or are there risks from impurities?
It is highly available through saponification. The fatty acid in used oil are converted into soap. The main risk is rancidity or unpleasant odors due to oxidation. This is solved by filtering the oil can using essential oils to neutralize residual scents. It turns hazardous waste into a cleaning resource.
Question number 7. Phosphates and algal blooms. Many detergents contain phosphates that suffocate rivers. What does green chemistry use to replace these water softening functions?
Phosphates cause eutrophication, excessive algae growth. Green chemistry replace them with silates, citrates, or silicates, which soften the water effectively without acting as a fertilizer for toxic algal blooms.
Question number 8. Odor neutralization. How does natural chemistry eliminate strong odors like fish or garlic without using synthetic perfumes that stick to the plate?
Instead of masking smells, natural soaps use molecular encapsulation or pH adjustment. Citric acid or essential oils like lemon chemically can break down the amines or sulfur compounds responsible for the stench.
9. Question. Skin safety. Dishwashers often suffer from dermatitis. How does this soap protect the skin very well, remaining strong enough to remove grease?
Unlike SLS, which strips the skin's lipid mantle, eco soaps use a milder surfactants and often retain natural glycerin, a byproduct of saponification. This humectant keeps the skin hydrated while the alkaline nature of the soaps handles the grease.
Question number 10. Natural antibacterials. Which natural chemical ingredients like citric acid or essential oils are genuinely effective against common kitchen bacteria like Salmonella or E. coli?
Organic acids. Citric lactic disrupts the pH balance of bacterial cell walls. Furthermore, essential oils like tea tree, thyme, and oregano have proven antimicrobial properties that can lyse bacterial membranes.
Good. And we continue with the third block and the impact it has on environment and what is expected of eco-friendly kitchen soaps. 11th question. Form performance. Consumers associate lots of foam with lots of cleaning. Is this a chemical myth? How is a functional eco-friendly from Activate?
Foam is mostly aesthetic. It does not clean, the surfactants do. However, to satisfy users, ecochemistry use foam boosters like cocamidrotopropyl betaine, derived from coconut, which creates a stable lather without the environmental toxicity of synthetic boosters.
Question 12. Concentration versus water content. Why is a solid or concentrate soap chemically more efficient than commercial liquid soaps that are 18% water, excuse me?
Water is a solvent that increases weight and requires preservatives to prevent bacterial growth. A solid bar is a pure chemical concentrate. It reduces the carbon footprint of transport and eliminates the need for plastic packaging or parabens.
And the final question, the kitchen of the future. Where is green chemistry heading to for the home? Are we close to soup that doesn't we need water for freezing?
Natural soaps have a high pH, alkaline, which is naturally hostile to most pathogens. For liquid eco formulas, we use food grade preservatives like potassium sorbate or sodium benzoate, which prevent microbial spoilage without being endocrine disruptors.
Question 14. Label reading. If we see anionic surfactants or limonene on a label, should we be worried? What are the false friends in a grain market?
Anionic surfactants is a broad category. Some are safe, derived from coconut. Others are not petroleum based. Limonene is natural but can be an allergen for some. A false friend is biobicet, which might only contain 10% organic material, while the rest is synthetic. Always look for specific certifications.
And the final question, the kitchen of the future. Where is grain chemistry heading to for the home? Are we close to soup that doesn't we need water for freezing?
We are moving toward enzymatic cleaners that digest grease and biosurfactants made by bacteria. No rinse soaps are tricky because you must remove the emulsified dirt, but we are developing polymers that encapsulate and flake off, which could minimize water usage significantly.
Thank you very much, Dr. Ignacio. We appreciate your presence, short but very important to carry a powerful learning. Any message you have to say?
Thank you so much for having me in this interview, and please be eco friendly. Use EcoGlow.
Well, with this we finish. We hope it has been your leaking and even more, that it has been informative. And I say goodbye, and remember, take care of the environment. We are ephemeral. The pollution is not. Thank you and good night.